Jeannie Chall wrote in her book that the traditional teacher-centered approach, and this is a woman who wrote this book after 40 years of doing research in education and being this expert that's very well respected across both progressive and traditional educators, that the traditional teacher-centered approach generally produced higher academic achievement than the progressive student-centered approach. So that's where the evidence is. Only one study of all the ones she looked at reported few consistent differences in achievement between the progressive and traditional schools, but it should be noted none found that progressive informal education resulted in higher academic achievement than more formal traditional education. So that's why we're on the traditional side. It's not out of being traditional for traditional's sake, it's because traditional education really does work. All right, so research also shows that more traditional approaches are also better, not just for the kids that are already achieving very well, but those that are those who are less well prepared, or those with disabilities, and at all social levels. And what's interesting is students taught with traditional approaches, even though the more progressive approaches emphasize self-esteem and the emotional component of things, students taught with traditional approaches actually tend to like school more and have higher self-esteem compared to students taught through progressive approaches. And there's a great study, it's the largest education study ever done in history. And it was called Project Follow Through, and the US government spent $1 billion in about 20 years trying to figure out for kids that were in poverty. It was a follow through on the Johnson's War on Poverty. And so what they did is, let's follow these kids that are in poverty, that are going through these, what the equivalent of what a Head Start program is today, and see what really works. And they solicited scholars from all over the country to come up with all these different educational models. And they said they tried them out in a lot of different settings, and there are like 22 different models that they tried out. And they did it in a very controlled fashion, all across kids, in different, across the country, metro areas, rural areas, you name it. They had all these different places. It involved about 10,000 children by the time it was done. It's the largest study ever done in human history. And what they found at the end of that is the kids that were taught with the most traditional approach, which is not an approach we're using, but bears some similarity. It's called direct instruction. That approach, by far and away, helped kids learn. I mean, it was dramatic. And the other models, all but one, which was the second most traditional one, all but one, they actually showed negative growth in kids. But the direct instruction showed the positive growth in kids. And, much to everyone's surprise, those kids were the happiest kids in terms of self-esteem and all the other emotional aspects that they also evaluated that as well. So it's a really interesting finding, one of the sort of hidden secrets of education history. Most people have never heard of Project Follow Through, but if you Google that, you'll see a lot of good information about it. And it's just amazing that the most traditional approach worked out. All right. However, big caveat. Research does not conclude that traditional approaches are better in each and every circumstance. That's why we said before, our approach here in our discussion is about where you lean. And we mentioned a heavy dose of common sense. Teachers have to make reasonable decisions. So it's not about being strict, interpreting the research overly strictly. All right, so more research on specific ways to teach specific topics to children of different age levels and ability is needed, but the general consensus, if you're looking to try to be in the ballpark of things that work, is to be more on the traditional side. All right, so our approach differs from most other approaches, where unfortunately when you hear people talk about educational theory, a theory in a scientific sense is based on evidence. Well, in education, very often, a theory is just speculation. I think that approach will work. It's just, that's all it is, right? There isn't necessarily a history or objective data to support it. So a scientific theory, obviously, is based on a body of evidence that's accumulated over a long period of time. One of the things that education as a profession has done is typically, if you go to like education schools, you'll actually be professors that say, you're not allowed to cite any research that is more than 10 years old. Why? Unless the study was conducted inappropriately, why do you care if it's older than 10 years? What you really want, if you're looking for evidence, is that the same findings over a period of decades have been found over and over and over again. And reading instruction, they've been doing research on reading instruction now for 50 years. The findings are incredibly consistent that phonics and phonemic awareness and the approaches that are associated with scientific reading instruction works far and away above everything else. Why would you ever discount the 40 of the 50 years of research into reading instruction that we have? It doesn't make any sense. So we believe that you have to look at the long-term accumulated evidence. And our approach is to be, to the degree that you can, research each subject area to see if there's actually good evidence there. And then, though it's not conclusive in all areas, well-conducted education studies, cognitive science, and the design of effective programs point to similar practices. What we do is we mix the classical approach, but we also take some insights for something called the theory of instruction, which is the book that actually explains, when I talked about that study was the largest ever done in human history, there's a very interesting theory behind how you present things to students there that's a very practical theory. And so what we do is we actually take some insights from there, and there's a theory in there that's a scientifically based theory about how students learn. And the programs that are used by the Baltimore Curriculum Project here in Maryland also use this approach. Now they use it in the pure direct instruction school. We're a classical school. We just kind of borrow some insights from what these guys are doing. But we're all kind of in the same family of being a classical school. There are a couple different, just to explain a little bit. You know, classical education, it depends on, there are a lot of things that fit into that category. So we're what you call a trivia-based classical education. We're kind of the pure version of classical education, if you will. There are other things that kind of fit within that, like the core knowledge program is also considered a classical education program. The direct instruction program is considered classical education. Classical in the sense of being more traditional for those things. All right, so it provides some useful ideas for design instruction. They're based on research, but if you ever attempt to read this book, it is really hard. It reads like a technical manual, and it's very, very difficult. So what we recommend is if you're going to get into this and kind of learn about some of these neat insights, it's a much easier book to read. It's kind of like the Cliff Notes in the English version of the theory of instruction, called Introduction to Direct Instruction. And so we can actually train teachers in this approach, so they have another tool in their toolkit. It's not the only tool, it's just a tool that most teachers, when they go through education school, don't get. And so we're going to make sure they have a full complement of tools to do that. Now we're going to briefly explain it to you. It's a sophisticated theory, but it's actually based on two really simple assumptions. So here it is. There are two main assumptions to learn from these guys. All right, so students can learn any quality through examples. Assumption number one. So the teacher says the color is orange. Students can generalize based on the sameness of quality. The teacher says, what color? Well, this is a circle and this is a square, but obviously it's the same as the color, and if you're not colorblind, you know that that's orange. We didn't have to teach the second example. We only had to teach one example, so students were able to generalize from that one example, despite its different shape, they generalized from the first. And so the theory of direct instruction that we're talking about here is really based on those two ideas. So if you take that as a premise, that you can learn anything from a set of examples that are arranged in a logical fashion that clearly communicate the more intended meaning, right? In other words, your presentation as a teacher is clear. It leaves no ambiguity for the student. Then what you do is say, okay, if that's the premise, how do we do that? How do we ensure that kids don't misinterpret things? So if students learn from examples, then let's present the examples in a clever way that makes learning easier. So there's a sophisticated set of rules which is called logically faultless communication, which is something most teachers haven't heard about, but it's really neat. The fundamental principle is examples must result in a single interpretation that students make with no misconceptions. So let me give you an example of something that we can teach to really young kids, maybe two or let's see here. All right, so take a look at this. The teacher says, I'm going to illustrate some fractions, and they say, well, here's 1/3, got one there, and we've got 5/7, right? We've got 2/5. There's a problem with this set of examples. Does anyone want to take a guess as to what the problem is with that set of examples? There's something missing. All right, did I stop? What's that? The problem is, in all of these examples, the numerator is smaller than the denominator. We did not present any examples or illustrate anything such as 6/5. And so what happens in fractions, and this is a known thing, this is why I'm using this example, we often teach students inadvertently a misconception that fraction means that little number on the top, big number on the bottom. We don't show enough examples. So one of the principles that direct instruction teaches is if you present an example of something, you have to ensure that you present a full range of examples so kids will not get the misconception that this subset that you're teaching is the totality of the possibilities. So it's important, and Singapore Math does this very well. It will actually go and show you early on things like 4/3. And one of the things that has always confused kids in fractions is 4/3. I don't understand what that is. Well, they illustrate it in such a clever, nice way with cartoons that all the bottom number is, this is a group. The bottom number says how many slices you divide your group into. The top number tells you how many things you've selected. So all you have to do is draw another group of 5, and then you count up the number of slices you have, and if you happen to go over to the next group, that's 4/3 or 6/6. And so it's a really clever way of making sure kids understand the concept. It is really very simple. It's just counting. But if you present it in a clever way, fractions become much less confusing. All right.